Now please see the second question. Discuss the continuity of the function fx is equal to 2x square minus 1 at x is equal to 3. The thing is similar. We have to only derive the definition limit of x tends to 3 fx. But your fx is what? Limit of x tends to 3. 2x square minus 1. Now we take x is 3, so it is what? 2 into 3 square minus 1. So 9 2s are 18 minus 1 is 7. If I take f3, so that will be what? 2 into 3 square minus 1. Again that would be same. So therefore we can express limit of x tends to 3 fx is equal to f3. So therefore we can say f is continuous and x is equal. Okay. First question, two questions are quite similar. But see the question number 3. We are given A, B, C, D. Here we have to discuss the continuity of the function. Now we have to consider the domain as a real number. So we just take it any. For any C belongs to R. Now related to C, which is a real number, we just take it like this. If limit of x tends to C fx, that is equal to limit of x tends to C. Fx is what? X minus 1. And that is equal to C minus 1. Whatever real number you keep here, you will get the same answer. Similar way, Fc is what? So Fx is x minus 5. So that is what? C minus 1. So therefore limit of x tends to C fx is equal to Fc. So f is continuous for every real number. For every real number. This is one point, but like this for every real number. Even, see, this is a method of representing the continuity of the function. We can also plot the graph or, see, in exam you can't do this one, but in an MCQ, we can check this way. We can check MCQ like this. If I take x, any real number, we start with the minus 2. So minus 2, minus 5, minus 7. Minus 1 is minus 6. 0, then minus 4. 1, then what? Sorry, 0, then minus 5. 1, then minus 5. If we plot the graph, minus 2, then minus 7. Minus 2, then minus 6. Minus 1, 0, then minus 5. 1, then minus 4. So if you plot the line, it will be a straight line in this circle. Now this line is a continuous line, unbreakable line. That's why this function is also, you can say, as a continuous function. Pause.
Done.
See the B. Discuss the continuity of this respective function. Fx is 1 upon x minus 1. X is not equal to 5. Because why we not take? Because otherwise it becomes an undefined term. So we just think for any C belongs to R but not equal to 5. Any C which is a real number but not 5. We just move on the same thing. So limit of x tends to C fx. That equal to, we can say, limit of x tends to C. Fx is what? 1 upon x minus 1. So you can say 1 upon C minus 1. Fc is nothing but 1 upon C minus 1. So therefore limit of x tends to C fx is equal to Fc. So therefore f is continuous. Continuous. Is that okay? Like this, another example. Fx is x square minus 25 upon x plus 1. X is not equal to minus 1. You know the factor of x square minus 25 is what? X minus 1, x plus 1 upon x plus 1. This x plus y cancel, so you will get what? X minus y. Now you can take it for every x belongs to, or C belongs to R. But we take the condition not equal to minus 5. No problem. We just derive the similar way. So say limit of x tends to C fx. But this time your fx is what? X tends to C, x minus 5. So that can exist C minus 5. Your fc will be what? So say C minus 5 only. Because here x we take it as a C. So you will get the definition limit of x tends to C fx. Okay. So therefore function is continuous for every real number. So therefore we can say that f is continuous. See, we are obeying only the one condition. If limit of x tends to C fx is fc, function is continuous at x is equal to C. But what is the C? C is any real number. So that means function is continuous for every real number. Function is continuous for every real number, means every point of its domain. So the function, these respective functions are continuous function. Simply you can see. Now the B, fx is a modulus of x minus 5. Discuss the continuity of the function. See, because of the modulus, the function will change. You can say fx is x minus 5 if x greater than 5. If x smaller than 5, we also express as a 5 minus x. And if x is equal to 5, then it will be what? 0, can I say. So one thing is sure, f5 is what? 0. Now here, we have to check the continuity at every point of the real number. But here, also we have to discuss the continuity at x is equal to 5. So first of all, we just take it. Limit of x tends to 5 minus fx. Means limit of x tends to 5 minus. Now you know that when x tends to 5 minus, means we left hand limit of the function. When x less than 5, x tends to क्या होगा? 5 minus. When x greater than 5, x tends to what? 5 plus. This you know. Even instead of here, you can express here, no problem. X tends to 5 minus. It means x is smaller than 5. When x is smaller than 5, your function is 5 minus x. So 5 minus 5 will be C. Limit of x tends to 5 plus fx. When x tends to 5 plus, it means x is greater than 5. It means your fx is what? Limit of x tends to 5 plus. Your fx is x minus 5. You checking this function when x is greater than 5. So again 5 minus 5. So therefore you get it, limit of x tends to 5 minus fx is equal to limit of x tends to 5 plus fx is equal to f. So therefore f is continuous and x is equal to 5. Now we have to think about the function. So continuity for smaller than 5 as well as greater than 5. Now for if a c is smaller than 5, we take it any c. Okay, this is the second case also you can say. Limit of x tends to c fx. This limit of x tends to c. When c is smaller than 5, we have to take a 5 minus x. So it is a 5 minus x. That is nothing but 5 minus. Now, and also, what is the fc? So say when c is smaller than 5, fc is what? 5 minus c. So therefore, limit of x tends to c, fx is fc. So f is continuous for every c smaller than 5. Now we get it, c greater than 5, number 4. Same thing, logic we think, limit of x tends to c fx is the limit of x tends to c. Just you check it. X tends to c. When c greater than 5, fx is x minus 5. But x is c, so c minus 5. fc is what? But c is what? Greater than 5. So we just keep the value c minus 5. So therefore, limit of x tends to c, fx is fc. So therefore, f is continuous for every c greater than 5. So therefore, f is, you can write continuous function. F is continuous. Okay. So see that here, for any real number given, we just go simply this definition. But modulus given, we have to use these 3 cases at a point smaller than that point, greater than that point. Why? Again I repeat, see, if I plot the graph of this function, see, if I plot the graph of this function, see, at x is equal to 5, it is 0. That's fine. X is, it is 1. 7, it is 2. 4, that is 1. 3, it is 2. So if you go on this, then your curve should be like this, union of 2 rays. So which makes it, the function is continuous at every point of the real number. Is that okay? See the next question, discuss the continuity of the function fx is x raised to n and x is equal to n when n is any positive integer. The thing is very similar, limit of x tends to n fx. But fx is what? Limit of x tends to n, x raised to n. Well, x raised to n means what? So limit of x tends to n. Can I say x into x into x into up to x? How many times? N times. Now we separate the limit. So it is what? Limit of x tends to n x into limit of x tends to n x into limit of, we separate the limits up to n times. Now x tends to an x, n is a positive integer, so we can keep the value n into n into n into up to n. How many times? N times. So it is n. So this limit of x tends to n, fx is n raised to n, and that is nothing but what? Fn. So therefore you can say f is continuous. X is equal to n. Is that clear? Now see the next, again the question, discuss the continuity of the function fx is x if x less than or equal to 1, is 5 if x greater than 1. Discuss the continuity of the function. Is that clear? Now at x is equal to 0, at x is equal to 1, and at x is equal to 2. First we go for at x is equal to 0. Now 0 means x is smaller than 1, this case only we have to use. So limit of x tends to 0, fx. Now what is the fx when x 0 is smaller than 1? So fx is x. And x tends to 0, so we keep 0. What should be the f0? Okay, 0 is smaller than 1. So fx is x, so it is a 0. So therefore, limit of x tends to 0, fx is x. So therefore, f is continuous Now second point we decide. At x is equal to 1. Now just think. At x is equal to 1, we have both the cases. Smaller than 1, then fx is x. Greater than 1, then fx is 5. So in that case, we have to use left hand limit and the right hand limit. Limit of x tends to 1 minus fx. This limit of x tends to 1 minus. See, x tends to 1 minus means what? X is smaller than 1. When x is smaller than 1, the function fx is x. So यहाँ पे x रखेंगे. That will be 1. So the left hand limit of this function at 1 is what? 1. And the right hand limit of the function at 1 is what? X tends to 1 plus fx. It's the limit of x tends to 1 plus. See, x tends to 1 plus. That means x is greater than 1. See, here we are selecting which fx we have to take. X tends to 1 minus means x is smaller than 1. That time fx is x. That time fx is x. But x tends to 1 plus. When x tends to 1 plus, that means x is greater than 1. That time fx is 5. So, respective that we have to accept the function. So here we take it as a 5. And limit of the 5 is 5 only, constant function. So the left hand limit of the function and the right hand limit of the functions are different. So we can say limit of x tends to 1 minus fx is not equal to limit of x tends to 1 plus fx. Is that clear? So therefore f is not continuous at x is equal. Is that clear? Now when x is greater than 1, it is only 5. Even you can say function is discontinuous at x is equal to. Now we have to discuss at x is equal to 2. We have to discuss at x is equal to 2 and 2 is greater than 1. So every time the function remains as it is 5. So we can say the function is continuous. See, limit of x tends to 2 fx. But limit of x tends to 2. 2 is a greater than 1 and that time function is 5. So 5, that is 6. And when f2 is there, it is 5. So limit of x tends to 2, fx is 1. So therefore, f is continuous. See here, this is a very good sum. These 3 different points related to that, we have to see the continuity of the function. Now we can plot through the graph even. See again, I plot the graph. See, you can check it the function. Here I am taking x and fx. Okay. If I take x minus 1, look, x is minus 1. Minus 1 is smaller than 1. So x we have to use. That is what minus 1. Minus 2, then minus 2. 0, then 0. 1, then 1. Simply. When you take 1.1, we have to use a 5. When 1.1, it is 5. If it is 2, then 5. If it is 3, then 5. See, I am taking like the integers, but 1.1 क्यों लिया? Because after the 1, whatever real number you take it, your function is 5. So when you plot the graph, see, when you plot the graph, please try to understand. When x is 0, it is 1. 0, sorry. Minus 2, then minus 2. Okay? So it is like this, see. 0, then 0. 1, then 1. Minus 1, then minus 1. Minus 2, then minus 2. So first graph is up to this. Negative value में तो infinite तक जाएगा. It will be stop at 1. Now this is 1 supposed to be on x-axis. After 1, greater than when you take, it will be a 5. 5 is somewhere else here, suppose I take 5. So at 1 is not 5. ये 5 है समझो, but 1.1 is 5, मतलब very next real number is 5 and 2 then 5, मतलब उसके बाद जो ग्राफ आएगा वो इस तरह 5 से इंफिनिटी होगा. Okay, so just to see, left hand limit of at 1 is what 1, but right hand limit is 5. Both the things are different. That's why, see, smaller than 1 it is continuous, greater than 1 it is continuous, but for 1 it is not continuous because these two are a different point. अभी मॉड्यूलस देखा तो मॉड्यूलस में क्या आया, 5 पर दोनों कर्व मिलते हैं. So the left hand limit is also 5, right hand limit is also 5. So the function in a modulus of x minus अभी जो देखा उसमें function is continuous, but here it is not continuous for that respective point. Please try to understand this point carefully.